The reason the prime factorization method is so useful is that every number has a unique prime factorization. For example, starting with 12. As long as you know two things that multiply to 12, you can always get to the prime factorization. So the first thing that pops into my mind is 6 and 2. 2 is a prime number, so we obviously can't break that one up anymore. 6 can be broken up into 3 times 2. Again, 2 is a prime, 3 is a prime. So we've reached the bottom of our factor tree, and we have 3 times 2 times 2. However, you might have thought, oh, 12 is 3 times 4. As you can see, when you break 4 into its prime factors, 2 and 2, you end up in the same spot. So no matter how you get there, you always end up in the same spot. And I really like this because you can be sure you don't have to think too much in the beginning. Whatever pops in your head first, you can just go with it. So let's do 4/9 plus 7/12 using the prime factorization method. The first step, you rewrite the denominators in terms of their prime factors. So right here we have 3 times 3. And since we just did 12, I don't have to redo it. It's 3 times 2 times 2. We then analyze which common prime factors we have. I usually use an underline to denote this. So we're good with the 3 here, good with the 3 here. However, we have two 3's here. We need 2 over here. So in order to get that, we need to multiply this number by something that'll give us another 3. In math, we're always allowed to multiply by 1. So we multiply by 3 over 3. We now have 2 3's on both. All we have left to do is get these 2 2's on this one. So multiply by 1 twice, of course 1 in terms of 2, 2 over 2 times 2 over 2. And as you can see, both denominators are now 2 times 2 times 3 times 3. The numerator here becomes 16. The denominator becomes 36 plus 21 over 36. 37 36 or 1 and 1 36. Oh, sorry, lost you there.